start on ocean plant engineering. Right, so schedule. Currently, Korean ship builders has a trouble on this ocean plant project, and I will show you some of the current situation and why we have such a big loss. So schedule is the most important item in ocean plant engineering. That is very similar to building construction or civil engineering. And standard means some standard parts or equipment or pieces, not including documentation, but standard means standard equipment parts. And in the future, I think ships can be also classified as a part of ocean plant. But this is beginning of a thought. And then there's a project called HS. I'll explain some example of these cases. Then later part will be covered by Duckyu. This is well known to Korean people, may not be to you or international student. He already passed away. He started Hyundai heavy industry, Mr. Jung, Mr. Founder. And is an old video. He's saying that when he started his shipyard, how many years ago? 45 years ago. He got the ordered new ship building, even though the shipyard is under construction. He got the order from the Greek owner, called him. By using this old money paper of Korea, because this includes a turtle ship, and probably he is, I don't know, General Soonhung, or I'm not sure. But anyway, he used this paper because there is no record of building of ships, because the shipyard is under construction at the time. By using only this paper and drawing, he got the order. That is a famous story in shipbuilding industry of Korea, and he's speaking about that story in video. So the contract of two big, that at the time this very big one, still is big oil tank, crude oil tanker. At the beginning of shipyard construction, right? Starting in 1972, when Greek ship owner Libanos, he's still coming to Korea. He's still alive, and he recently ordered a new tanker to Korean Hyundai shipyard. Onassis. How many? Did I talk about Onassis? No. Do you know who is Onassis? One person. Only one person. Okay. You know John F. Kennedy, right? John F. Kennedy. President. He died, right? His wife, Jacqueline Kennedy? Jacqueline? How many knows Jacqueline? Jacqueline? Yeah. She married again after John F. Kennedy died. Right? She married with Onassis. He's a Greek man, big businessman, ship owner, big shipyard, rich man. So Jacqueline Kennedy becomes Jacqueline Onassis. That was an old story, 30 years ago. So he was famous. Anyway, she's a big, so brother, but not brother-in-law. So it's an interesting story. Onassis divorced, and married again with Jacqueline Kennedy, right? So the Libanos was brother of Onassis's previous wife. So they are family anyway. But there has been an oil shock in 1973, in between when the shipyard is constructed, because of the Middle East war between Egypt and Israel. Suez Canal was closed. So that's why oil prices doubled or 4 times higher because of the transportation problem. That's why the old economy shut down, not shut down, coming down in worldwide, so that the ships are canceled while the shipyard is under construction for the Hyundai Heavy. So that was a very big disaster to the Hyundai Heavy company. But that was saved probably by government, I guess. The government lent money to him or his brother. So they established a new shipping company. So that company, money coming from the bank, and that company buy these canceled ships and started a new shipping company. Now, the two companies, this company becomes a Hyundai shipping company now, and Hyundai Heavy Industry, both are two big companies now. So it's a success story, but it is a very troubling situation at that time, at the beginning of Hyundai Heavy. I'm telling this story because the situation in Korean shipyard is very similar now, at the beginning of this slide. So that this time is different, right? Because of the oil price down, at that time is a bit oil price up, but now the canceling is coming from ocean plants, many of them. So that Korean shipyard has a very difficult times. So why those ocean plants has troubles? Because of that each project contract requires a different specification for equipment and design. That is also very similar to building construction. Each building has different specification, different equipment, and different design. I'm living in a house rather than an apartment. Apartment is very standardized housing, right? One building, the segmentation and equipment and shapes and size, very standardized. Window, door, kitchen, right? Bathroom. But in my case, I'm living in a standalone house. There are about 70 houses around my home. Right? Each house is different. Right? Shape, number of floors, size, material, all different. They, even including myself, we want to be different. Right? I want to have a different house as a separate differences. That is very different, similar to ocean plant cases. Comparing to shipbuilding, ships are ocean plants are different. In terms of, even though ship can be produced in series, say, it can be ordered, say, in this case, at the beginning of the ship building there has been two ships of same size, same oil tank. Right? That is typical in shipbuilding. Sometimes it can be 10 same series ships constructed with one design. And then the equipment and also design, equipment, and other things that can be standardized. So that for the construction similar to ocean plant, production, scheduling, procedure, survey is the validation or test by owner or other the register, ABS or DMV, register, Society of Register. They are doing a testing whether the construction is executed according to the design. So that survey method and way is different. That's why the cost increased due to this increase of number of different equipment and purchasing and procedure and design. Procurement. Procurement means procurement for equipment. And mostly the equipment is coming from Norway, Denmark, or Germany, or including some part from Japan. That is very special to each project, so that there has been a delays. And testing also included by testing and survey and validation is come together. They have a different surveying method. Standard is different. Testing standard is also different. So most important was schedule delay due to new procedure, new each project, and also domestic procurement coming from far away. That gives you delays because communication problems and testing. But domestic Korean equipment suppliers, they are good for equipment for ships, but not good for ocean plane. That is another problem. This is captured. I take a picture coming from Samsung Engineering Company. That is not Samsung Shipbuilding Company. That is an engineering company. They are doing only designing and engineering. But this is a big one, big company. They are mostly doing plant engineering or land-based plant engineering, but including also ocean plant. But at the entrance of that building, there is a big building. It says floors about 15, number of floors. They are saying about 5,000 people are working together in that building. At the entrance, I found this one. What is it? Specification code is a number to the equipment. Specification is I'm trying to buy a pump. What kind of pump? What kind of pressure, capacity, material flow, and material of pump, and voltage of operation. That kind of thing is we call specification for purchasing of equipment. And code is number system. Number means number for that specific pump. Some similar to your phone number. Phone number is code number of your telephone or your social security number something. And transaction. Transaction means input to the computer. Transaction. When you go to the banking machine, I want to draw $10 from the banking machine. So you are doing some secret code, password, and something like that. That includes one transaction to my account. One transaction to withdraw $10. It's communication between computer and database transaction. Entry is input to the database. One site user interface. Right? That is their slogan to handling equipment. Because in a ocean plant there are about 300,000 equipment cases included. They are assembling 300,000 different equipment together to build one ocean plant. So this is a big database. But each one should be purchased from Norway, from Denmark. Right? So it's a very complicated business. And then it comes with the delays because of something wrong with this kind of database. Same story, more detailed one I will not explain. standard is important. They noticed the big three shipyards of Korea. That is Hyundai Heavy, Samsung Heavy, and Daewoo Shipbuilding and Marine Engineering. Those are big three. Also big three in the world, right? In the world. They understand that standard in equipment is important, so that they started with a project with American Bureau of Shipping, because they are doing testing and survey to develop a standard on material. Material means equipment specification and designing for outsourcing. Outsourcing means they constructed blocks or modules of the ocean plant outside of shipyard. But because the ocean plant is big, the number of modules, number of blocks can be hundreds. Right? And that outsourcing goes to different sites, different country even. Right? China, Philippines, also inside Korea. So they should be well maintained, and standard of quality should be averaged, right? So that when they are finished and brought into the shipyard, they should put together, welding together, so that standard is also quality, material, standard level of accuracy should be maintained. Also in project management procedure. Offshore platform. I'm trying to explain you that ship and also some kind of ships are classified as ocean plant. This is a typical ocean plant. We already see this one, right? Once again, so that I'm remembering yours. The FPSO is for processing. Processing means production, right? Processing for production. And then storage. There is a compartment for storing the oil, processed oils. And then when ship is full, then the shuttle tanker is coming to offloading. This is offloading. Effective in remote deep water location, and they can be depleted, then they can be moved. We already see this. And we call this is a topside. Topside is one chemical plant, a chemical processing plant. This is topside. So this is drill ship, but this one is a processing unit, or this is processing unit of topside. So green part can be topside. Red part can be hull, very similar to ship. But in this case, this is an aircraft carrier replacing airbase, land-based or sea-based airbase, floating airbase. Largest, I don't know whether it's still largest, but Nimitz class is 100,000 tons. And 30 knots, and nuclear power plant, and 90 aircraft. Right? We can think this one as an ocean plant. Topside is airbase. Underbody hull is a ship. Right? So put together. So conceptually, it can be a topside and hull together. So it can be an ocean plant. How about this one? Mobile harbor. It is not ship, but it looks like a ship. This one is a mobile harbor. This is a container ship. Very small size mobile harbor. We can say this one is a floating container crane. Right? Not usually this one is land-based, right? Land-based. But this time this is a floating container crane. Right? So once again, I can say this one. Top side is ordinary container handling gantry crane, and bottom side is ship. But in this case, this is a twin hull ship. Right? two body, underbody, hull. So you can say top side and bottom side separation is one kind of ocean plant. How about this one? This one is only conceptual drawing coming from MIT. But they want to design a floating nuclear power plant. This is similar to one of the floating ocean plants. Right? I don't know whether the underwater shape of this part probably can be a large cylinder, right? Large cylinder to support this top side. So in this case, the top side is a plant, but not oil processing plant. This time it's a nuclear power plant. Top side is a nuclear power plant. And bottom side, below the water level, can be just a hull, simple hull. Buoyancy, right? A cylindrical shape, probably. So we can say a separation of top side and functioning part and bottom side. Bottom side is usually used for buoyancy and storage, something like that. Right? Another example is wind power system. So this is a tendency coming from here to here. It is not happening yet. Some examples are existing, but not popular yet. But the trend is going in this way. So this is a land-fixed one. We already see in Korea, even in Korea, in say the mountainside. Right? Also, some bottom fixed, but in the shallow water of ocean. Right? We already see this one in Jeju Islands also. But in the future, it can be a floating type, not fixed type. The body is not fixed into the earth, this end, so it's a floating, so it can be moving. Right? But it is good because it can be very big, I don't know, 5 megawatt something. This can be 1 megawatt, about. This is less than 1 megawatt, 100 kilowatt something, size. And noise is the problem, noise of this wind power. So it's far away from the land side. Anyway, in this case, also this is a kind of ocean plant. Right? Floating and top side can be wind generation. Can be same as land-based one, but size is bigger, but the idea is same. Okay. So this is one example of ocean plant FPSO project. And see that this is Australia, map of Australia. The site is northwest corner of Australia, and that is expanded to this picture. And you see that there is a land of Indonesia. So you will find that Australia and Indonesia is very close by. And the site here, it is filled, the site is. And that is picture only. This is a conceptual diagram. And they have a central processing facility. They call CPF. And this is FPSO, floating production, storage, and offloading, or off-take vessel. And then this is shuttle tank. And they also have a pipeline, underwater pipeline too. They probably choose whether, because this is around about, they are saying, I remember, 200 kilometers something. And this one is ordered to Samsung Heavy, CPF. And this one is ordered to Daewoo. So it has been a big project to them. And still they are working on this project. Not delivered yet. The original schedule was last year, but they are delays. They do not want the owner, the project owner. They do not want to get the facility earlier. They want to delay the schedule because of the oil prices down. If oil price is going up, they start to rush. That is a typical business cases. And this, I'm trying to show you the project organization. Impex is a Japan company, Imperial oil company, oil producing company. They have a joint venture with Australia. Total is based on France. The main body is, but Total Australia. 25%, 76% Impex, and then the joint venture. So then headquarters is located in Tokyo. So that that Impex is the main body, right? And see, the big contract to Samsung and Daewoo is only one small box in total project organization. So that you can expect the amount or size of the whole project is much bigger. Probably more than 10 times of that money. This is trying to show the top layer, the blue color is a sequence of timeline. So the well drilling, they started from drilling, exploration, and then subsea systems. The down onto the seabed, there should be a subsea system. So drilling wells and Christmas tree, and then FPSO is coming, production and storage in the floating type, and then shuttle tanker goes to transport the gas and oil. And then in land side, you should have a supply to consumers. So that is a timeline from well drilling to, and business is divided into segmentation, and then oil business and gas business and LNG and FLNG, that is coming together with the gas type, oil or gas. FLNG is full name of this one. The FPSO for LNG. And VLCC already know that. And umbilical rise and flow line is the cable or line going into the subsea to well drilling. FPSO, you already see this. FSRU is regasification. So it's going for the gas business, LNG type. And then ships, drilling rig and ships are used for any of type of this one. Also wellhead, processing, pumping, compression, and umbilical and riser and Christmas tree together, and blow-off system, BPA. They are used for both of the system, but there is a separation between them. And also transportation, shuttle tanker, pipeline, including and in the land-based system. And once again, the well, offshore processing, pipeline, LNG, transportation supply to our customer. The energy state for the gas station. This is for gas. LNG supply chain. LNG. And you should see that the temperature down, and pressure and temperature is going together to make a liquefaction and gasification. So high pressure and high temperature. Medium pressure, medium temperature. And low pressure and low temperature. So transportation and plant that need a liquefied format with less pressure. So transfer station. So LNG ships should be designed for this state. So production and processing is doing this way. Well, used for, in this case, in home or other places, in land-based site. Good? Question? No? Then we can go on to the view continuation.
Okay, as you can see in this picture, this is one company named Fiatech, and this company is comparing the 5 stages, all stages that to make a contract to end the work. The first one is scenario-based project planning and automated designing, and the procurement and every process. So we can the form of the contract seems like this. First, the client and the contractor interact, and the contractor and suppliers or the subcontractors interact. That the suppliers and the client does not interact each other. This form of the EPC contract is named EPC, and this EPC is the initial of the engineering, procurement, and construction. So compared to the original contract form named AFC, the contract have to design the installation and procure the necessary material and construct it, and either through own level or by subcontracting part of the work. The most important thing of this form of the contract is the contractor has to carry all the responsibility and the project risk for the schedule as well as the budget, because this contract follows the LSTK named which is initial of the lump sum turnkey. So the budget is also the contractor's responsibility. That a little bit additional explanation for the lump sum turnkey. It's the pay at once and make it just before the plant starts. So if the user put in the key and just turn it on, then he can use the plant. So yes. And the main function of the contract are as follows here. Define the scope of work and technical requirements, describe the conditions of the delivery, ensure correct payment at correct time for company to contractor, define risk sharing, protect company from a failure in delivery by contractor, and provide performance incentives for contractors. So the past contracts seems like it is divided into several various stages, like base designing and engineering, procurement, construction, and maintenance is separated to the various contractor or the companies. But in present, the engineering and procurement and construction is merged into one contract. So this is the good for the efficiency, but because they can make the process 3 stages coincidentally. But so like this contracts are developed or advanced, the future may be the every stages will be merged into one contract, but it will be making the risk of contract more harder. So it could be the non-profit for this contract. And I want to mention about the trends in offshore projects. The first one is what the oil companies want to have requiring for the offshore contract. The first one is the requirements. First one is changing the form of the contract that is originally AFC to EPCIC. EPCIC is a little bit more advanced version of the EPC contract, and as you can see in here, the engineering, procurement, and construction was the EPC, and additionally the installation and the commissioning is the more from the EPC. So this type of the contract make more responsibility to the contractor, and the client wants the contractor the more quality of the technology. And the second requirement is they need engineering management for applying the engineering management for the part of the project management. So, and the third requirement is want to contractor be the globalization. Yes, these three are the requirements, and the second trend is that the AFC is not efficient for the efficient engineering project. And third trend is that the developing the automated system named EM to decreasing the human error. And fourth one is the EM systemize the work on stage FEED to decrease useless cost and man hour. That FEED is the initial of the front end engineering and design. Yes, these four are the trends of the offshore project. And the primary reason that oil companies use the EPC contract is first one is the total responsibility is on the contractor, and the second one is the time efficiency, and third one is for the focusing on the client. They don't need a big project team to manage the project. And last, the client doesn't need many people to manage the project, so they can concentrate on the core business. So that make the more efficient things. So they use the EPC contract. And the EPC general principle is under there, the single point responsibility, a fixed program with the delivery date, a fixed price. A contractor gives turnkey product guarantee, and EPC contractor is the principal. So a typical EPC contract has the following structure over here. The appendix A to J it is a little bit complicated. The scope of work and compensation or schedules, the administration requirements, companies document, deliverables, insurance of subcontractors, contractor specification and standard form of guarantees. So, and then we have one more type of the contract. I want to compare between EPC and EPC management, which called EPCM. They have differences between the two contracts. If the EPC contractor has the most responsibility on risk or the time or contract prices or procurement and quality performance and owner involvement and all else, the EPCM contractor share the responsibility with the owner. That the EPCM contractor usually advises the owner to make the projects go on. So the task in EPC contracts is the first one is equipment supply and yes. So equipment supply is the negotiated and signed by EPC contractor and supplier, and supply selection solely chosen by EPC contractor, and scope of supply or process warranties, project financing, legal costs may be lowered. So, and top 5 causes of failure of the EPC contract is first one is requirement unclear, lack of agreement, lack of priority, contradictory, ambiguous, imprecise. And second one is resource, the lack of resource or resource conflicts, turnover of key resource, poor planning. And third, the schedule, the too tight, unrealistic, over optimistic. And fourth is planning, based on insufficient data, missing items, insufficient details, poor estimate, and last one is risk, the unidentified or assumed, not managed. So, while the project has hanged 3 parties coincidentally go on, for the engineering, there are several disciplines of that is very independently hanged. So we have these 7 disciplines. First one is instrumentation and control and layout and piping and process, electrical, equipment, civil, HSE. HSE is the health, safety, and environment. So yes, we can see this 7 discipline, 8. Okay, 8. So one more is plus. So we can in this table we can notice the characteristic of the engineering discipline, which the activities is needed for the each discipline. So in the case of the equipment, they need diagrams and geographical drawings, architecture drawing, and site work specification. So equipment needs the diagrams so that the equipment and the civil and piping also need the diagrams too, activities, so they have to collaborate each other. So the process of the every EPC, the contract is shown in here. The first one is 3D plant modeling, and it's made the 2 parts of the process. One is the constructing the drawing and material takeoff. Second one is the first part make the construction drawing, make the material list, and material takeoff, make the procurement, and to get them to the next process, the warehouse, and to two parts combined to the construction site. So these are the approximate stages of the APC contract. And as you can see, the first one is 1989 and 1993, and third one is 2004, and the last one is 2013. As the time goes on, the latest one is having more tags comparing to the past ones. So increasing the of tag items in ocean plants is the trend. And the procedure of the detail engineering for one is starting with the piping modeling. It goes to electric and control modeling and the AFC PANID. The AFC is the approved for construction that usually the contractor get approval to the client, and then it is last stage to AFC 3D modeling. These are the procedure of the detail engineering. Thank you for listening. And these are the abbreviation that you can also read for the contents. Okay, thank you.
Okay. Hello to everybody. The topic of today is about methane hydrates. Since someone may not know anything about methane hydrates, I found a really interesting video that you can watch. In a few words, it's like ice with methane inside. It's a really simple concept.
In the ocean, pressure increases with depth. The phase boundaries shown in the diagram delineate the theoretical pressure and the temperature limits under which methane hydrate should be stable. The water temperature in the ocean decreases with depth, in this case to about 4 degrees Celsius at the seafloor. Within the sediments, however, the temperature rises again due to the geothermal gradient. So methane hydrates can only form within the hydrate stability zone, which is delineated by the phase boundaries and the actual temperature distribution.
So basically, this diagram shows that there are certain range of temperature and pressure. This is the depths in which methane hydrates can form and be stable. So in the Earth, there are two possible zones where you can find methane hydrates that are in the polar zone and under the ocean. Now, someone can wonder why I'm talking about methane hydrates. I'm talking because there is a really huge amount of methane hydrates in the world. As you can see from the map, the amount of carbon inside the methane hydrates is more than double of the sum of all the other fossil fuels. So we have a really huge amount of it. And as you can see, it's distributed all over the world. So my question is, can methane hydrates be the future energy source, and why? Why yes, why not?
Isn't there any application yet of this gas, like forming a kind of fuel or something?
There are like some countries that are spending a lot of money in trying to extract it, and if I read, if I remember well, the only one who succeed is Japan, because as you know, Japan have to pay a lot of money to Russia or to other country who has oil and gas reservoir, and Japan has a lot of methane hydrides, so it can be really useful for Japan to have it instead of paying money to Russia or to Saudi Arabia.
I heard that in Korean Duckyu Island.
Yeah.
Under the Duckyu Island, there are lots of methane hydrates, and I heard it from this. And Korea tried to extract natural gas from methane hydrate, and it was successful.
Okay. So you think this
yes,
could be?
yes,
Okay.
it could be energy source, some transmitting.
Okay.
I think in energy problem, we don't have much choice because if we are running out of oil, we have to use it.
Okay.
So I think there's no much choice. And one advantage is I think most methane hydrate according to that map is in the near sea.
Yeah, exactly.
I think that can be one of the advantages. Whether this depth is
Okay.
Yeah, I heard that when you burn the methane hydrate, it produces less CO2 than when you burn the oil.
Yeah, it's a good point, because methane is like the best fossil fuel among the fossil fuel, because it has the lower it has the lower carbon dioxide production per energy produced.
Yes,
So it's better to burn methane instead of oil. So maybe it could be a solution for the global warming, because you can reduce the carbon dioxide production compared to the other fossil fuel. But if you compare to the renewable sources, of course, it's worse, because you will produce carbon dioxide as well. Someone else has?
So it's a very thin gas, so it's quite difficult to handle, so especially to contain, to store. Also, but it would be a good thing to use the gas, otherwise it would be released slowly but steady to the environment.
Exactly, that's a really good point.
It's quite bad for the environment. Yeah, I guess it's quite difficult to use frozen gas to liquefy it, and so the whole process is quite difficult.
Yeah, one of the main disadvantages is that it's really difficult to remove from the seabed, especially because, as you heard in the video, it is stable under certain range of temperature and pressure. So if you are when you are trying to remove it, you can make it go up in the atmosphere. I mean, you are not able to, if you are not able to control it, you can release in the atmosphere, and you can increase drastically the global warming, because methane is one of the worst greenhouse gases in the world. It's like 20 times more worse than carbon dioxide. So, okay, you more or less you say the main advantages and the disadvantages. One of these is the environmental problem, because it requires a lot of drilling operation. So you can you have to there is a huge impact on the seabed of the ocean. Okay, the second discussion is more easier, and I found three breakthrough innovation in the recent year. One is the sky sail, that basically, if you know what is kite surf, is the same concept. It is a parachute that is tied to a ship, Then is a sail drone that is an autonomous wind-propelled sailing vessel. And the third one is a really easy, is an edible six-pack ring. So I would like to know which is the most useful breakthrough innovation according to you among these one.
What is the edible six-pack ring?
It's like you know, to store the bottle like of beer, you need plastic things, and these are like the fish can eat them, so you don't create a problem for the ocean ecosystem.
I think the most breakthrough innovation is the edible six-pack ring because it relates with the environmental issues.
I agree with you.
Yeah. It's very useful. And so Skysail is, I think, impossible to move with only the...
No. It's like to help, to give more power. Of course, you need... yeah. But compared to the non-conventional sail propulsion system, you save space, and I think, and it is really more powerful. So it's a good idea. I mean.
Yeah, I agree. I think the edible six-pack ring, that's the most value. And the silver is just a nice gimmick, but
Yeah.
just information adding.
Okay, no one has other. This is the. Thank you for the attention.